If you open the applet that I have attached to Classroom by PHET, PHET, you'll see you have the choice of the Rutherford atom or the plum pudding atom. I've chosen the Rutherford atom here, and what you do is you click on the blue button here, which starts firing alpha particles at the thin gold foil. And these little purple dots, these are the alpha particles. These are the atom. So you have your electrons around the outside and you have your nucleus in here. Now this experiment was about establishing that there must be a nucleus, really. Now, if you've looked at the plum pudding version, you'll see what was expected to happen when they fired the alpha particles at the gold foil. And what you see here is what they actually saw. You see lots of the little purple dots, the alpha particles going straight through as if there's nothing there, which is what you saw with the plum pudding model as well. But you can see that there are particles being deflected through different angles. And every so often, you might have to sit and watch for a while, but every so often you'll see one that bounces right back. So you have three things here, three phenomena that are being seen. One, you have the alpha particles going straight through as if there was nothing there. Two, you have alpha particles being scattered through a range of angles. And most of them went straight through, as you can see from here. Some of them were scattered through a range of angles, and very few, about 1 in 100,000, bounced right back. And while I'm talking, I'm looking to see if we see any of those that bounce right back. You'll be able to review the video yourself and see, look at your own version, run the applet and see for yourself. But these three things provided evidence to suggest that since the alpha particles went straight through, most of the atom must be empty space. Since they were deflected through a range of angles, some of them, the only way that that would work is if they were coming close to something with the same charge. So we know the alpha particles are positive. They knew the alpha particles were positive. So for them to be deflected like that one was, they must be coming close to something which is also positive. And the closer they get, the bigger the deflection is. We saw there that that was a very big deflection, whereas some of these are being deflected very slightly. That one, for example. So the closer they get to this positive thing, the bigger the deflection will be. So that tells them that there must be a place in the atom where all of the positive charge is. Then 1 in 100,000 bounce right back, like that one did. Now what that means is, because the alpha particle is actually quite a massive thing, quite a heavy thing, then it must have hit something which has also got a lot of mass. So that 1 in 100,000 bouncing right back, what that told them was there must be a place in the atom where virtually all of the mass of the atom is. So you have a place where all the positive charge is, and you have a place where virtually all of the mass is, and you have an atom which is mostly empty space. That's how the evidence came up with, or led them to, the nuclear model of the atom.